Hello dear students of plus one medical, non-medical and respected teachers. Today I am going to discuss again a very important topic that is known as inelastic collisions in one dimension and in two dimensions. So first of all, what do you mean by an inelastic collision? A collision is said to be inelastic if only momentum remains conserved, but there is loss of kinetic energy after collision. And when the two bodies stick to one another after collision, then collision is said to be perfectly inelastic. For example, mud thrown on a wall is an example of perfectly inelastic collision. So first of all, let us discuss inelastic collision in one dimension only, which is perfectly elastic. Suppose we have a body of mass m1 moving with velocity u1, another body of mass m2, but it is at rest, that is u2 is 0. So when this body collides with another body at rest during collision, this is a position, and they stick to one another if the collision is inelastic, and the combination of the both masses having mass m1 plus m2 moves with velocity v. So v is the velocity of combination after perfectly inelastic collision. So as the collision is inelastic, only law of conservation of momentum is valid. So m1 u1 plus m2 u2 is the total momentum before collision is equal to m1 plus m2 into v. As u2 is equal to 0, second body is at rest. So v will be equal to m1 u1 upon m1 plus m2. So this gives the velocity of combination during one dimensional inelastic collision, that is when two bodies stick to one another after collision. So V is given by m1 u1 upon m1 plus m2. And from this equation it is very clear that velocity of combination is always less than the velocity of the body A, that is initial velocity u1, because this m1 upon m1 plus m2 is less than 1 when m2 is not 0. So it means there is always a loss of kinetic energy during an inelastic collision. So loss of kinetic energy takes place, and we can calculate the loss of kinetic energy also. For that, suppose E1 is equal to half m1 u1 square is the initial kinetic energy before collision, because u1 is the velocity of first body, u2 is 0. So initial kinetic energy before collision will be E1 is equal to half m1 u1 square. Similarly, final kinetic energy, total final kinetic energy after collision will be E2 is equal to half m1 plus m2 into v square, total mass, because bodies stick to one another. So therefore, using this value of v, E2 comes out to be E2 is equal to half m1 plus m2. From this equation, substitute value of v square, m1 square u1 square upon m1 plus m2 whole square. So m1 plus m2 cancels. So we have E2 is equal to half m1 square u1 square upon m1 plus. Now loss in kinetic energy is equal to initial kinetic energy minus final kinetic energy, E1 minus E2, or loss in kinetic energy is given by half m1 u1 square minus half final kinetic energy half m1 square u1 square upon m1 plus m2, or half m1 u1 square can be taken as common. So it will be 1 minus m1 upon m1 plus m2. LCM m1 plus m2, it will be m1 plus m2 minus m1, m1 cancels. So we have loss in kinetic energy is equal to m1 m2 u1 square upon 2 m1 plus m2. As m1 m2 are positive, u1 square is positive. So it means loss in kinetic energy is positive. So it means there is always a loss of kinetic energy after an inelastic collision. Clear? Now, inelastic collision in two dimensions. Suppose a body of mass m1 moving with velocity u1 before collision, making angle theta with the x-axis. This angle is theta. Or this is the direction of motion of m1 and this angle is also theta. So angle in direction of motion and x-axis before collision for body of mass m1 is theta. And suppose body of mass m2 is at the origin and moving along x-axis with velocity u2 along x-axis. So when they collide, suppose they stick to one another, so total mass is m1 plus m2, but their direction change. So when two bodies moving in different directions collide with one another after an inelastic collision, their direction of motion also change. So now this is the direction of motion of both the bodies, which is making angle phi with the x-axis. And suppose v the velocity of combination of the bodies after inelastic collision. Then this momentum m1 u1 of first body before collision can be resolved into two components, m1 u1 cos theta along x-axis, m1 v1 u1 sin theta along y-axis. Similarly, after collision, v the velocity of combination, momentum of both the bodies moving velocity v together can be resolved in two components, m1 plus m2 v cos phi and m along x-axis, and m1 plus m2 v sin phi along y-axis. So this is when two bodies stick together, and such a collision is said to be two-dimensional inelastic collision. Okay. Now along x-axis, by applying law of conservation of linear momentum, before collision, what is the momentum of body, first body of mass m1, m1 u1 cos theta along x-axis plus m2 u2. This is the momentum of body of mass m2 along x-axis because it was moving along x-axis before collision with velocity u2 is equal to m1 plus m2 into v cos phi. So total momentum along x-axis of the both the bodies after collision. So this is equation number 3. Similarly, along y-axis we can apply conservation of linear momentum. Now m1 u1 sin theta is the momentum of first body of mass m1 along y-axis before collision, and momentum of second body before collision along y-axis was 0 because it was moving along x-axis only with velocity u1 u2 is equal to m1 plus m2 v sin phi because now both are moving together with velocity v and making angle phi with x-axis. So this will be the m1 plus m2 into y v sin phi. This will be momentum of both the bodies along y-axis. So both are 3 and 4. So knowing masses m1 m2, if angle of theta, initial angle will be known at which it strikes the body b2. So knowing m1 m2 u1 and theta, u1 u2 and theta, we can find v and phi from these two equations by dividing them, and we will tan phi, so we will get phi, and using the value of phi in any equation we can find velocity of combination after inelastic collision. So this is all about inelastic collision in one dimension as well as in two dimensions. So till then, stay tuned. I will post next video. I will start very important chapter, simple harmonic motion. The next video I am going to discuss simple harmonic motion and its characteristics. So all the best, be happy, good luck.